General Physics 2 is brought to you by Physics Classroom. Is electromagnetism essential to life? Let us explore the concept of electromagnetism and its applications. What did you do today? Did you use or hear a motor at work in a mixer or blender, refrigerator and washing machine, hair dryer, fan and vacuum cleaner? Did you hear a buzzer or doorbell sound? What about a cellular phone? If you saw or heard these devices or machines, you observed the combined effects of electricity and magnetism at work. Scientists learned how to use the relationship between electricity and magnetism to produce electric currents and to make machines that would make these devices function. These scientists and inventors have made amazing changes in the way you live. Electricity makes magnetism. On the morning of February 16, 1820, an important discovery was made by accident. Professor Hans Christian Ørsted in Denmark was giving a lecture on electricity to his students. He closed a switch to demonstrate the flow of current. There happened to be a compass nearby. Every time the professor closed the switch, the compass needle turned. Ørsted had discovered that an electric current is surrounded by a magnetic field. His discovery made him conclude that a current-carrying wire produces a magnetic field. This led to the principle of electromagnet. What is an electromagnet? An electromagnet is a magnet that can be switched on and off. It is a solenoid with a core. The strength of an electromagnet can be made stronger by increasing the number of turns on the core. There is a simple method of finding the relationship between the direction of the current flowing in a conductor and the direction of the magnetic field around the same conductor. The method is called the right-hand rule. The magnetic field lines produced by a current-carrying wire will be oriented in the same direction as the curled fingers of a person's right hand, with the thumb pointing in the direction of the current flow. Magnetic field and electric current. Shortly after Hans Christian Ørsted's discovery that electricity produces magnetic field, scientists experimented with the opposite possibility. In 1831, Michael Faraday, an English scientist, discovered that a moving wire through a magnetic field could cause an electric current. At about the same time, an American scientist named Joseph Henry made a similar discovery. A current produced by a magnetic field is an induced current. Michael Faraday concluded that when a wire is moved through a magnetic field, a current is generated in the wire. This process of generating current by the relative motion between a wire and magnetic field is called electromagnetic induction. Applications of electromagnetic induction. What is the difference between the generator and a motor? What is a generator? A generator is a device that converts mechanical energy to electrical energy. It consists of a U-shaped magnet that produces magnetic field, and insulated loop of wire. The wire loop is attached to a power source placed between the magnetic poles. The power source slowly begins to rotate the wire clockwise. As the wire loop moves, it cuts through the magnetic lines of force that induce current. As the rotation of the wire loop continues, it moves parallel to the magnetic lines of force. When the wire is in this position, no lines of force are cut, therefore, there is no electricity. As it moves further clockwise, the lines of force are cut again, producing electricity. The alternate movement of the wire causes alternating current. A rectifier changes alternating current into direct current. A moving loop cuts through a magnetic field, which generates current in the wire. The alternate movement of the wire causes alternating current. A generator operates on the principle of electromagnetic induction. What is a motor? One of the most important uses of electromagnetism is in the electric motor. An electric motor is a device that converts electrical energy to mechanical energy. A motor contains a movable electromagnet. If an alternating current is supplied to the electromagnet, its poles are reversed. Where it was once attracted by the opposite pole of fixed magnet, it will next be repelled. This process is repeated many times each second. There are many types of electric motors. Each is designed for a particular purpose or use. They all operate on the principle of electromagnetism. What is a transformer? The alternating current through power lines is at an extremely high voltage. Before alternating current from the power plant can enter your home, its voltage must be decreased. The current must flow through a device called a transformer to decrease the voltage. The transformer regulates the voltage that enters the system. The operation of a transformer operates on the principles of both electromagnetism and electromagnetic induction. A transformer is made of two coils of wire, called the primary and the secondary coils. These coils are wrapped around an iron core. As an alternating current passes through the primary coil, the iron core becomes an electromagnet. As the current changes direction many times each second, the magnetic field also changes its direction, and induces an alternating current in the secondary coil. Let us have a simple activity, picture analysis. Examine the pictures of the two types of transformers, the step-up and the step-down transformers. Differentiate a step-up transformer from a step-down transformer in terms of the number of turns in the coil. What did you notice? How will you differentiate a step-up transformer from a step-down transformer, in as much as the number of turns in the coil is concerned? Now let's try solving a simple problem involving a step-up transformer. The number of turns in the primary coil of a step-up transformer is 125 turns. If the voltage input in the primary coil is 110 volts, how many turns must the secondary coil have to produce a voltage output of 220 volts? Solution. By applying the simple concept of ratio and proportion, voltage input over the number of turns in the primary coil equals voltage output over the number of turns in the secondary coil. Thus the number of turns in the secondary equals 220 volts times 125 turns divided by 110 volts. Therefore the number of turns in the secondary equals 250 turns. Let's now solve a simple problem involving a step-down transformer. A step-down transformer has 243 turns in its primary coil. If the voltage output is 50 volts, in the secondary coil which has 81 turns, what is the voltage input in the primary coil? Solution. By applying the simple concept of ratio and proportion, voltage input over the number of turns in the primary coil equals voltage output over the number of turns in the secondary coil. Thus the voltage input equals 50 volts times 243 turns divided by 81 turns. Therefore, the voltage input equals 150 volts. The previous discussion revealed the wonders of electromagnetism, as manifested in its applications, namely, generator, electric motor, and transformer. These are basically the devices that initially facilitated ease and convenience in our way of living. Scientists utilize the relationship between electricity and magnetism to produce electric currents and to produce useful machines that would make these devices work and become functional. These have made amazing changes in the way we live. And then again, may I ask, is electromagnetism essential to life? Imagine life without it. Thank you.